All right, welcome everybody to the Artificial Intelligence in Healthcare podcast series. I am your host, Matt Kins, Segment Development Manager for Healthcare and Access Americas. And what I do is I largely work with solutions in the healthcare space that can benefit from access technologies. I am joined here today by Roger Milford, CEO of 𝐢𝐴DENT. Roger, why don't you tell the viewers here today a little bit about yourself and the company?
Thanks. Pleasure to be here, Matt. I'm Roger Milford. I am the CEO of 𝐢𝐴DENT Intelligent Technology. We're a Vancouver-based company that develops software specifically for access cameras. They all fit in. Our software fits inside the camera. We don't require any servers or other things.
Fits inside? You mean like in the box?
Well, on the DLPU.
Yes.
So I've spent 23 years in healthcare. Prior to joining this company, I headed up the artificial intelligence team at a major radiology PACS company, and so I've gone from really detecting brain bleeds and lung nodules to detecting people in vehicles. Our team is made up of largely people who joined from that same company, and so we feel like we're experts in the imaging field at this stage. Yeah,
absolutely. And so I think we'll do a little bit of housekeeping just for the podcast itself as we flow. So this is a first in a series of podcasts where we're going to be exploring the exciting and ever evolving world of artificial intelligence in healthcare. Over the course of the series, we'll be bringing in several subject matter experts and discussing how the healthcare industry is benefiting from video-based artificial intelligence. This series aims to foster in-depth discussions. We believe that insightful dialogue is crucial for successful artificial intelligence deployments, as context plays a critical role in building robust and nuanced artificial intelligence programs. As we embark on the exciting journey in AI, let's dive deeper and explore the complexities of computer vision together. All right, this podcast specifically is going to be addressing, at least mostly, reasons for bringing Roger on, discussing positive outcomes that we have seen in the space, what goes into making a model. I know everybody's going to be very curious about that. I know I want to hear more about it as well, too, specific to your programs, and what we kind of see the future of this evolving into if we could make it anything we wanted, right?
Yeah.
And so, thank you for joining everybody here, and let's get into it. So, Roger, there's a few reasons why I brought you on to this series, right? And one of them is you have extensive tenure in the space of healthcare, right? And I happen to find your approach to artificial intelligence incredibly grounded. Mm-hmm. So why don't you tell everybody, so myself, what is artificial intelligence to Roger?
Sure. So first of all, I'm going to give you a very high level of artificial intelligence, not specific to cameras.
Mm-hmm.
There's different types of artificial intelligence. I specialize in the computer vision side of things. There's also natural language processing and a few other areas that I think we're seeing melding together more and more, and we'll continue to work on those in the future. One of the things, having worked in what would be called the modern early days of artificial intelligence, is that I always wished that the artificial would be replaced by assistive. I think there's a lot of fear mongering. I think people have watched too many sci-fi movies and things where AI has become something that people fear is going to kill them and eat their children. It's going to take away their jobs. It's going to spy on them. And I think that in the past, we've seen companies that have been so interested to see how close they could come to the line of what's legally acceptable. And I think that in the future, we're going to see more and more companies acknowledge that, yes, the line is here, but we don't have to go to that line. We can do AI in an assistive way, as I said, with that assistive intelligence, where we're not collecting your personal identifiable information. We're not spying on you. We're not aiming to take away your jobs, but rather take away the menial tasks that you do that allow you to do your job better.
People don't like those?
I heard an interesting story last week, actually, with a lady who was an artist. Mm-hmm. And she said that in her life, she wants the artificial intelligence to be able to wash her dishes and vacuum her floor so that she can focus and spend more time on her artwork and not have the AI come and do her artwork. And that lady understood artificial intelligence for the future perfectly. That's exactly what we do when we design things. We want to design something that fits in the background, something that is like the Google system that tells you when you leave your office you'll be home at 6:30.
Tell your wife,
You don't
your
have
loved
to.
one.
Yeah, you
I
don't
will
have
be
to
home
do
at
anything about
6:30,
that.
yes.
It just automatically knows, and it doesn't interfere with your drive home. It's just critical information for you to know at the right time, and that's really where we try to focus: is how do we get the notifications of what's happening without having to have someone sit there and watch and say, this person is doing this, that person is doing that.
Absolutely. And what you shared there, in my experience, and even having conversations with people, like even in the PAX industry, they're fearful of losing their job with it. And largely, I very much believe that we want to improve the efficiencies of humans, but the human's in the loop. It's making that critical decision, that actionable event. They're making that decision, not the computers. And I very much agree with what you're saying on the assisted intelligence.
Let me give you an example of why I think that it's a kind of a scaremongering way of thinking. Is that I started working in radiology on AI in 2016, and the big fear then that we're hearing from radiologists is that in 5 years there'll be no need for radiologists. And here we are now, 8 years later. I don't know a single radiologist that's not working in radiology. But you know what? Every one of the radiologists that is using AI in radiology is just doing it so much better than what they did without it.
Absolutely. It's natural progression. And you also make comment too specifically about laws, and I'll say the word codes, is that in my experience in the healthcare industry, and just even in technology in general, codes are downstream of culture, right? And culture is driving those changes. And it has to be that way for it to be organic and flow. And so, I mean, humans drive culture. Computers don't drive culture. These things aren't sentient, right? And so I feel like that's a very often missed step. So I really appreciate you sharing that. And you mentioned developing new models, right? Can you, without sharing any secret sauce, right? You have a wonderful product and you have a ton of experience in this. What goes into making a new model?
Yeah. The first thing that we'll do is it's critical for us to speak to the end user and totally understand the issues that they're trying to solve. Bill Campbell is a role model of mine. He started Intuit, and he used to tell his sales force that if they had to go out to see a client, he did not want them asking the client, what do you want? He would say to them, go to the client, find out what their problems are, and come back and tell us. We pay excellent people to fix problems. And I've tried to adopt that a little bit in our company. So generally our first step is to meet with people, understand what their needs are. We've developed enough things right now that we also have enough Lego pieces that if someone has a problem, no two problems are ever the same.
Right.
And so as they have these problems, we can say, you know what, 80% of the work is done. We can put these Lego pieces together and customize a little bit to tweak it. As we develop models, most AI models are done by labeling individual images of people. So, you could say this is a cat, this is a cat, this is a cat. And then we pump it through a supercomputer. Sometimes the models take 3 or 4 days, sometimes 2 weeks if it's a big model. And we get a model out at the end of the day. The key to that is that the quality of the data going in is essential to making that model effective when it comes out. AI, our CTO always says that AI is like a child where you take it into your home, which is our lab in this case. You train it, do this, be polite, have manners, do what's right. And then eventually you have to take that model, that child, and send it off into the world.
Hope it does well.
And you just wait for that phone call where it's like, hey, Dad, I've crashed the car, or I'm drunk, or whatever else it may be. Yeah. And then you have to bring them back in and say, okay, well, come home, I'll train you some more. And AI works very similar to that. Yeah. And so we don't always know what we're going to get out at the end of the day with the model, but you can certainly get a better model by making sure that the data that you put in is legitimate.
Yeah. No, that makes perfect sense. And I like the analogy as well, too, as being a parent. You do hope they make good choices out there. But in degrees of accuracy, what becomes, a customer-facing product, right? And I know you do a ton of testing, but can you just break that down just from a real high-level perspective, right? Because obviously, garbage in, garbage out, we have been saying incredibly long time in the hardware business, right? Specifically that of video, garbage in, garbage out. You can't process anything you can't see. Yeah. And I think the expectation sometimes it just just does. And that's not how it works in the real world. And we operate in the real world where our customers hold us accountable for the quality that's going out.
The first thing that I'll say, and I think it's been a detriment to the AI industry as a whole, is that for too long, too much has been promised. We used to joke around that we'd ask people, do you know the difference between machine learning and artificial intelligence? And the answer to that is machine learning is coded in Python and artificial intelligence is coded in PowerPoint.
Yes.
Because most of the time they just totally make it up.
100%. Yes.
And so a lot of people have been promised a lot of things by AI. And the one thing that I will say, first of all, is that there's a misconception that AI is one thing. It really isn't. Every type of AI is different to the next. In the same way that you can't say that anything with four wheels is a Ferrari, because if I have a skateboard, it's very far from what a Ferrari is. And so, there are people who will claim all sorts of things with artificial intelligence, things that I wouldn't even classify as artificial intelligence, as being sold as artificial intelligence. And so people have been disappointed in that. The second problem that we have is the self-driving car conundrum, which I kind of refer to is there's thousands of car accidents on the road every day, but if one driverless car has an accident, it's headline news.
Absolutely.
So when we send things out, there is an expectation that if this is being done by a computer, it needs to be super accurate. And so while we never claim that our AI is perfect, we want to make sure that when it gets out into the real world, there are as few possibilities of making errors as possible. We aim for zero false positives, zero misses. We don't always get there, but
being practical
it certainly
as well.
is significantly better than what people can do at the moment.
100%. I absolutely agree. And just kind of unpacking what you were talking about too is like data sets going into generating a model.
Yeah.
How do you go about validating the data going in?
Yeah. There's an interesting thing. A lot of artificial intelligence data is gathered from all sorts of free places on the internet. As a company, we've made a policy not to do that because we don't know, who owns that data. And we've seen some
Privacy.
issues with companies now saying, you used your data model to read our books. They were copyrighted and you are not allowed to use those models anymore. And we don't want to be in a scenario where we have customers where someone comes to us and says, hey, you can't use this model anymore, because that means the customer then goes offline. And so we take data, we create a lot of our own data. None of the data is taken from places where we don't have permission from it. And we label our own data. So to create a model for, if I want to pick up, garbage cans,
sure.
I need somewhere in the region of between 25 and 75,000 images that we have a very good team who will sit and label blocks around garbage cans and say, this is a garbage can, this is a garbage can. We then run those through those models and then we own them. One of the other secrets that we do is we many of the models out there have data sets that are taken by students in universities and they use their iPhones and they take pictures all at like eye level. The reality is when it comes to security cameras, these cameras are all placed really high up on ceilings.
To get the field of view.
You're getting a field of view that is not the same as the standard models. Right. And so we use models with our partners. We train models from cameras. We have a whole lab set up in our office. We've built ATM machines and beds and all sorts of things that we train using our own data from security cameras. And we use the model as the full aspect ratio of the screen, not just a smaller section that looks at
because that's models. What you're going to get in the real world. You're going to get that.
The great benefit of doing that is that you don't need to have movement on the screen. No matter where on the screen I see that person or thing, I can tell that it's there.
No, and I think it's very important for people to understand too where they're getting their data from to generate these models that we're using.
Yeah.
And speaking of like how we're using them, I myself have been part of programs and I'm grateful to be part of them because I consider myself fortunate in that space where we're doing fall prevention, right? And we've seen like 80% reduction in falls, right?
Yeah.
But why don't you explain some of your positive outcomes that you've been part of?
So we started working with a hospital in Wisconsin probably nearly 2 years ago.
Wisconsin?
Yeah.
Little near and dear to my heart. Yeah.
They had a very long corridor with a little alcove at the end, which was a blind spot for the people who were sitting there. As you can imagine, after COVID, the staff shortages are
Mm-hmm.
immense. The people are overworked.
It's not going away.
And they just didn't have enough people really to look at. I think it was 3:00 in the morning. A guy came into the doors using every bit of energy that he had, and then fell, but in that little blind spot area where no one could see him. And he was there for about 45 minutes, and it caused a major concern, obviously, for the person as well as the public image of the hospital. It's not a good look when someone comes into your hospital and ends up having an emergency is not attended to. We started working with them on developing the fall detection software, and only about a week into our trialing of the very first version of our software, there was a lady that came into the hospital in the exact same way. All the energy she had, she fell on the floor in that little blind spot area. It was about 2:00 in the morning. Within about 3 seconds, we picked her up that she had fallen, sent a notification to the hospital staff, and within 13 seconds, they had her in a wheelchair and were attending to her. So these are real use cases, and I
Actionable
think
data.
this is why I got into healthcare in the first place. Is that I feel there's ways to make a real impact on people's lives.
Absolutely.
And it makes me, I enjoy AI because it's a new way of doing things really to benefit people. And so when you look at the scary parts of AI, I understand that they're there, but know that there are companies out there, many companies, not just us, that are looking to do AI in a way that is beneficial, that does help people's lives, save people's lives, and really make things better as a whole.
That story is like eerily similar to what we've seen, like the state of Massachusetts do with Laura's Law.
Yeah.
I mean, it's not related, but it is, because theirs is more like wayfinding and things like that. But this is such a, you made me think of that when you're telling me this story. It just sounds, and if you're curious, Laura's Law, it's one of those things where you need to be able to have a system and people to respond to people trying to get into the emergency departments to seek care, because these places can be complex just organically by their layout because they've been remodeled over time. Or if you're not familiar with an area, maybe you're visiting, and you have no idea what you're doing. You're already under enough pressure trying to, basically self-report. And then the fact that you've actually saved a life, right? And the fact that somebody was fallen and when there was nobody there because they're out doing other tasks. It's not that they weren't responding. It's just they needed something to assist them, right? And again, that makes me think of that immediately too. It's a good law. It really is. And so I wish more people just adopted it in general. But that you made me think of that in saying that.
The interesting thing with something like the fall detection is that, we developed it specifically for hospitals and healthcare facilities. Up until now, I think we've sold about half of the units to places outside of hospitals, anywhere where someone works alone. And so we're seeing a lot of the industry is going from a security type industry to a safety type of industry. And in a way, to me, that makes me feel even better. It's nice to catch the bad guys, but it's even nicer to save a life. And so when we work with people, places that you would never think of, airports, we have an airport that's put our fall detection on the escalators. So if someone falls on an escalator, you don't have the whole escalator, all the people on the escalator now falling on top of the fallen person. We can stop that.
That's got to be tricky with the heights changing too. Like you talk about field of views.
Camera placement is important.
Yeah. Oh yeah, I imagine so.
Super important. Places like data centers, they use carbon dioxide for fire suppressant. They don't want to, if they have a fire, they don't want to spray water on all their servers.
Right. Be a little bit
of course, if it's also a place where people work alone a lot. And so if you have an emergency and that thing leaks carbon dioxide and someone's on the floor, they're likely to fall over and not be able to get up, and there's no one around to see them. So again, we can trigger help on that. No,
that's incredible. And when I look at what's coming in the future, because what we're doing now is amazing, right? But before I go to the future part, is you mentioned in your story that one of your early models of fall, right, for fall prevention systems. What goes into making the model better over time?
So we started off with a product that used pose estimation. It was the little stick figure that you see went over the person.
It's like in the Ghost Hunter shows,
and
right?
it works very well. Now we're
appears.
working on future versions that will go back to that, but we found that the strength of the GPU that it runs on, the DLPU and the cameras, needs to be strong enough to run that.
Absolutely.
And what is critical for any type of behavior movement is to see how many recognitions we can get per second. And so with the early model, we were getting probably 3 recognitions per second, where by moving back to the block and training models specifically for people to fall, we can now get 7 to 8 per second. So we get a much higher rate of recognition. A lot of the time it's going back and redrawing the data sets. We had an issue where the data sets that we were using at first were picking up chairs as people. And we realized at that stage that what it was is that we were drawing the boxes too big, and the boxes that included chairs. And artificial intelligence is the type of thing, with most computer code, you can go into the code and say, oh, there's a problem here. You can imagine a supercomputer that, we train our models on that runs for 2 weeks. There's so much data there that there's no way that you could ever go back and
continuously running too. Yeah.
Continuously. And it's just not possible to do that. So it involves retraining a new model. Now we're constantly training new models. There's the saying, I don't know if you've heard it, that data is the new oil. And so, data is valuable, but just like oil, it gets used up. And so we have TV screens in our offices where we have cameras pointing at things that we're counting cars, for instance, or detecting boats. We train a whole lot of our stuff. Our families have become like stunt people. We've fallen downstairs in our homes. We've filmed ourselves doing things and just creating data and constantly adding and improving that data into the models. And over time, we're on version 5.2, I believe, of our care product now. So it's
had a few iterations.
It gets better and better every time.
Yeah, and how do you release that to the people? Like what's the vehicle for releasing those?
Yeah,
updates?
so a lot of people, I think that the fear with many people is that they're like, oh, I don't want artificial intelligence on my camera because the camera is a living thing that's learning who I am. And that's really not the case at all. When we load a model onto the camera, that model is a fixed model. It's not doing constant learning. It's not picking up who you are and getting better.
Not auto learning.
It's not auto learning.
No.
So
a little bit of a misconception for some people. Yeah.
We
learn themselves right out of anything.
We are training models, and what we do a lot of the time that helps us too is that we use very, very strong intensive models to train our smaller models.
That makes sense.
And by using a strong model that identifies things and teaching the little ones, it's the same as you would have an older kid teach a younger kid.
Yeah.
We're very constrained with size, so we need to be able to squeeze that elephant into the shoebox. And that's one of the ways that we do it. And so those big models give us data that we just couldn't create. We can label data with models and then run them through people at the end to make that much quicker.
Yeah.
But it is a good way of improving all the time, and we're constantly looking to improve. We also see the hardware improving all the time. And so as the hardware gets better and better, we have to prepare for what that hardware is going to be like 2 years down the line.
100%.
So a lot of the products that we're developing in-house now are things that cannot run on the cameras today. But we're hoping that in the future, when those cameras are strong enough, we'll be so far ahead of the pack that no one can catch us from there.
Well, and not only that, but it gives you time to validate as well too, and test things, and they flow. And that way it's more organic for a consumer at that point as well too. They're not necessarily funding all the development that's going into it. This next job type of thing, where it's like what you discussed about like people going around with students taking pictures. Is that even the angle we need? And camera placement, camera selection, lens placement, all those things, which I can nerd out on. I won't for this, but I can just enough to bore everybody that's listening, and I'm not going to do that. All those things are relevant in what we're building. And when you talk about building into the future, we look at artificial intelligence usage in healthcare. The appetite is immense in this space. I have seen wild things in my time dealing with this. Whether it's generated pre-trained transformers doing auto charting for the GPTs, or pre-canned emails for doctors for more of a softer feel or more aligning with company branding, right? The provider's brand, like what does this feel like for more of unified messaging, right? Yeah. I see it where obviously fall prevention models are hugely in vogue. there's some new crazy stuff where they're doing like blood pressure monitoring optically, so you don't have to like do the round and some wild stuff that's eventually coming to market or will, or maybe it doesn't because it goes through clinical trials and what have you. And we're tiptoeing on that line. What do you see, or maybe even what are you most excited about in the future of AI in healthcare?
Yeah. There's so many things that create data right now, right from your Apple Watches through to visual data creation.
Apple Intelligence?
And Apple Intelligence.
Just came
new
out.
buzzword.
Yeah, that's right. I do like how they refined artificial, though. I do like that. It's like your assisted intelligence.
Mine is assistive intelligence. So I think that you do want to have an assistive intelligence because that's something that can allow you to really focus on what you're good at and allow everything else to fall towards the computer. So as we look to things that are coming in the future, so keep in mind, I started in artificial intelligence in 2016. There's no career path that I could have imagined ever getting to this point because that just wasn't a thing when I was younger. And so I kind of stumbled my way into it. I was doing my MBA in 2016, and one of the courses was on artificial intelligence. And being a product manager for the radiology company at that time, my immediate thought was, geez, if we could use this stuff in healthcare, imagine the possibilities on it. And then we saw companies like Zebra, some really excellent, Cure is another one, where they were looking at images and being able to determine incidental things. So I'll give you an example. You're a mountain biker, young and healthy, you come off your bike, you damage your elbow or your shoulder, and you're going to have a CT scan. While you're having the CT scan, that radiologist might be looking for the cracks and do the report on the cracks. However, the AI will be looking at the whole image, and they might see, while he's focused on the shoulder, they might see, you've got lung nodules in here. And at the end of his report, it would say to him, while you're doing your report, we noticed that there are some things that might be suspicious. Have a look to see if that could be a lung nodule. And so there's an incidental type of finding there. I think that that's one of the ways. The very best AI, as I said earlier, will work in the background. We don't want to disturb workflows. So even when we design stuff, we don't try and eat the whole cow. We focus on what we're good at, and that is sending notifications and making our vendors' products better, making them smart. And so we stick in our lane. We're very good at detecting what we're seeing, and we send that information into another system, which is the typical system that the user is using as a workflow. So that user's workflow requires no additional training. Everything works and is seen as something that's native to them.
Yep.
And this way we can take away those little things and make them better at doing their job.
Yeah.
And I think that's really where we're going to see some of the focus. Of course, with the new data, there's so many different things, but there's also a lot of things that I think people have watched too much TV. It's too much sci-fi. The reading the number plate and the reflection of your eye.
I've seen this one.
There's a lot of people that think that that's really a realistic thing. Yeah. And there's two ways of looking at AI. I think the one is more the Elon Musk, the computers are going to come and kill you. And then the other one's more the Zuckerberg, where you can make, it's not as smart. And I tend to be more on the humans keeping control of what the AI is doing. I don't really foresee that we're going to have bad players that ultimately win the AI battle. The key to understanding AI is that at the moment AI is probably about as smart as a 3-year-old child or a smart dog, where my dogs will sit at the window and if they see a person they'll bark. Same type of level as that.
It's a good analogy. Yeah.
But you're not getting the false positives. You're not getting the tiredness. People, instead of watching 50 screens, think of a building where the security guard sits at the front desk. He's got a monitor. He's got 100 different cameras that he's trying to watch.
Not possible.
The guy comes in with the Amazon package. He's busy signing for the package. And while the boss drives into the back garage, a vagrant slips in the side and holds him up. It's so easy to miss that. Where with AI, it's always watching. It's always on. And we can stop things like that pretty effectively. To send that guy who's signing a package a notification or an alarm to say, hey, look at this camera right now. This is what's happening. If he gets that notification, he can immediately look and see what's going on and take action. And I think that's especially in healthcare. Healthcare is a very zero-sum game. No one's going to buy a new product unless they can see either a reduction in cost somewhere else. So it has to save them money somewhere else, or else it has to generate new revenue for them, which is less likely in the hospital scenario these days because they're already charging so much. And so really, we have to be able to show as vendors that our products are good enough to save you significantly more money than what it costs somewhere else.
Yeah. Well, also, there's a lot of events that go unattended.
Yeah.
That as part of branding or a patient experience, resident experience, what have you, that need to be responded to. And what I'm hearing from what you're saying here too is you believe a lot is going to be how we're going to notify people and keeping the topology flat. So like these models and these alerts aren't just logistical or analytical readouts later. There's value to that for making changes within an organization, but you have to know where to make the changes, right? But bringing in live alerts, live time, that's the gold standard. And so being able to consume relevant data without changing core duties of the person, I think that's what I'm hearing a lot of.
And don't get me wrong, there's an area for understanding the data. So, I might want to know how many people visited this patient this week. Or
how many doctor to patient panel.
How often was there a nurse in the room? These are other things that are not, you don't need a notification, but it's very interesting to see over time different levels of care. Again, we're not trying to be the police of the nurse. We're trying to make their lives easier. And maybe the benefit of that is not that they have to come to the room more times, but maybe now because the camera is monitoring the patient and it doesn't even have to stream that video anywhere.
Right.
It acts as a sensor. But now that we know that that's watching the patient, as you have the faith and the belief through using it and trying it and knowing that it's going to give you no false positives and no misses, I don't have to wake the patient up every 2 hours to go and make sure that they're still doing okay. I can now ease the workload of the nurse by allowing them to go in fewer times and really focus on helping the patients that really need help at that time.
Absolutely. Prioritization. Absolutely. Well, Roger, this has been amazing. I'm really grateful for you attending this podcast. This is fantastic. I hope everybody listening has gotten some value out of it and will join us for the future ones. And with that, thank you all.